I'm going to introduce just another question. What happens if we have something like this? Well, let's figure it out. I can multiply the a times each of these terms. Let's try to do it without using the distributive law. So a times a squared is a cubed. A times negative ab, that's going to give me a negative a squared b. A times b squared, well, that's that. Then I get this. And I end with a b cubed. Is there anything here that I can cancel out? Anything at all? Or anything I can combine? Well, let's look at this. This is an ab squared. This is an ab squared. If I add ab squared and I subtract ab squared, I get 0. This is a ba squared, and this is a negative ba squared. Because a squared b is the same as ba squared. So what do I have left? I have just this. So this actually is a really nice formula. Why is it a really nice formula? Would you even recognize whether you had a product that was of this form? Like, let's say this was some 7x to the 9 and this was negative 3x squared. Would you really recognize that your product was of this form, of the form a plus b times a squared minus ab plus b squared? Probably not. But then why would this formula be useful? Well, if I have this, if I have a sum of cubes, I might want to use this formula in the opposite direction. I might want to start with a sum of cubes and turn it into a product. And why might I want to do that? Well, if I want to see where a sum of cubes is 0, it's really nice to be able to write it as something times something else, because with a product, if either piece is 0, then the product is 0. And if neither piece is 0, then the product is not 0. So it tells us exactly when this is 0. And there's one more situation that you could encounter if you have something like this. If we multiply this out, what we get is this. And once again, if we have a difference of cubes, we might want to know when it's 0. Well, it's going to be 0 when one of these two pieces is 0. Much easier for us to find when this is 0, then this is 0. I mean, unless a cubed happens to be identically equal to b cubed. Okay, so maybe we'll write out how we get this. Let's do this multiplication and just make sure, because I just wrote this formula and I didn't show you that it was true. Maybe you don't believe me. So I multiply the a times all three terms, and that's what I get. And now I multiply the negative b times all three terms, and that's what I get. Negative b times a squared is negative ba squared. Negative b times ab is negative ab squared. And negative b times b squared is negative b cubed. So, what do I have here? I have an a squared b. I have a ba squared. This is the negative of that, so I can cancel them out. I have an ab squared. I have a negative ab squared. Cancels out as well. And you see we get this term right here on the right. So, showing you that both of these rules actually do hold true.